Hello dear viewers. In this video, we'll be presenting to you our heart model. This is a labeled diagram of our heart model, which will aid you in understanding the unidirectional flow of blood in the heart. As the heart muscle contracts and relaxes, the valves open and shut, letting blood flow into the ventricles and atria at alternate times in one direction, and prevents backflow of blood into the ventricle. The following is a step-by-step illustration of how the valves and chambers function.
Firstly, deoxygenated blood from the upper and lower part of our body flows into the right atrium via the superior vena cava and inferior vena cava respectively. After the right ventricle contracts, the pulmonary valve closes and the tricuspid valve opens to allow the deoxygenated blood to flow from the right atrium into the right ventricle. When the right ventricle contracts again, the tricuspid valve closes and the pulmonary valve opens. So, deoxygenated blood flows into the left lung and right lung via the pulmonary artery, where blood is once again oxygenated as oxygen diffuses into the blood. Following that, the pulmonary vein then transports the oxygenated blood from the lungs to the left atrium of the heart.
After the left ventricle contracts, the aortic valve closes and the mitral valve opens to allow oxygenated blood to flow from the left atrium into the left ventricle. As the left atrium contracts, more blood flows into the left ventricle. When the left ventricle contracts again, the mitral valve closes and the aortic valve opens. So, oxygenated blood flows into the aorta via the aortic valve, where it's distributed around the body via 3 arteries. This then forms a double circulation where the deoxygenated blood returns to the vena cava and the cycle repeats, which helps transport oxygen all around our body.
Limitations of model. Although our model is a fairly accurate representation of how the human heart works, there are still some limitations which we can improve on. Firstly, our stop motion may not effectively aid our viewers to visualize how the contraction of the ventricle allows blood to flow into different valves and chambers. It does not show how the heart pumps the blood such that it circulates out around our body. Another limitation that exists will be the scale of our heart model, as the veins as well as the size of the chambers and valves are not entirely to scale. Furthermore, the vessels are not flexible. Thus, it is not the best representation of the heart model. Lastly, the many small veins and arteries such as the coronary arteries are not represented in the model and will require more elaborate planning and scaling.
I'm Fabian, register number 19. I'm Tongfei, register number 21.
I'm Xiaoyun, register number 39.
I'm Yo Yong Shen, register number 30. Thank you
For
Watching our video.
thank you. 8 seconds, 8 seconds.